morning, everyone. Welcome to the fifth capability building session of Udyam 4.0 Smart Manufacturing Forum. Today, the topic, as you can see on the screen, is the smart energy management in the manufacturing sector. So we're going to learn about how saving energy can help you to reduce some of the operational cost in your plant, which are the hotspots where energy is consumed abnormally, and how you can save upon energy and utilize most of it so that your operational cost is reduced. We have with us as a speaker Mr. Sagar Dubal. He has a 15 years of experience in the business domain. He runs his family-owned business as well. But he had a keen interest in technology and especially areas such as condition monitoring, smart energy management, machine connectivity, etc. And that's why he set up his own firm as well, which is known as AutoBits. So without much of delay, I'll hand it over to Sagar. Yeah, over to you, Sagar.
Hello everyone. Thank you for joining in today. I'll keep this session very short and simple so that it's very easy for everyone to understand the concepts that I'll be sharing today. And if you got any question, you can raise your hand. And in the end, we'll have some interaction also. And first, I'll start with some basics. Then we'll go with how it is, what it is. And then we'll see some lab demonstrations of how smart energy management has improved and helped other companies. So to start with, you might wonder that what is this image? So this is a child who is looking into the machine for glasses. So today I'll be showing you how you can view your factory performance in a different way, and I'll provide you with a pair of new glasses that will help you look things differently today. So without any further delay, I'll just start. So smart energy management, why? So why do you need this kind of technology? That is because in these changing times, profits are getting smaller, revenues need to be increased with the same capital. So that is what this technology helps you. That is helping you maximize on your profits from the small loss centers. So you might be facing losses in some center, and helping you reduce those losses is one way to increase your profit. So that is the one reason that you should opt for something like this, which will help you optimize your efficiency, will help you increase the efficiency of your assets and optimize your workings. Then it is, when do you need it? So obviously you need it today only, because it's been a long time that we've seen a lot of disruptions, and this is one of the biggest disruption that has come to industry in quite some time. When you ask that is it for me or do I need this? Yes, this is for all these companies that are looking to do something new, to get better at what they're doing, and to provide their customers with something better. And how? So for how, I'll be speaking now. What the how is, what's told, that's I'll be speaking now. That later on slides are for how. So there's a famous quote by Mr. Peter Drucker that if you can measure it, then only you can change it. So by measuring your energy demands, your energy consumption, your efficiency, then only you can reduce or optimize or increase something. If you are not able to measure it, or if you're not measuring it, there is no chance of improvement. So for improving or for optimizing, the first thing is measuring it. And that is one biggest tool that smart energy management gives you. That is helping you measure something, helping you measure everything. So when we look into manufacturing process, there are three key M's that are there and which everyone is aware of. So the man, material, and machine. So technically, like till now, we've got systems like ERP, CRM, HRMS, accounting solutions, which help us manage and monitor the man and material. But how do you monitor your machines? How do you know if they are working efficient? So you can say your marketing person is efficient if he's giving you sales of X percentage or X amount. You can see your cost of production is low. If you know that you are buying in 100 kgs of material and you're selling 99, then you know there's only 1% of loss. So you know it's efficient. But how about your machines? How do you know if they're efficient? So till date, there has not been any dedicated tool for managing and monitoring your assets till now. So I'll be speaking about those tools and how it has helped companies worldwide to improve on. So in any machine, there are three major things, 3 to 4 major things. First is you provide that machine some raw material, you give some manpower. So you feed in something. There are operators who are feeding it, supervising it. Then you change the consumables on and on. And the most critical thing is you provide with energy. Without energy, everything you can't do anything. You can automate manpower, but energy you can't do anything about it. So energy comes in multiple forms. So energy can be using your power, that is the electricity. It can be using utilities like gas, steam, compressed air, heaters, chillers. These all are some forms of energy that you use in a machine. So now it is very much critical to monitor how the energy is being utilized, and is it utilized as the per the benchmark figures, or the efficiency is going down. So now before going how it is, I'll just give you a teaser of what can do for you. So why is it important? So saving and managing energy can help you on millions of rupees annually. So it can help you avoid breakdowns. So now if you already know that something is going to fail, then you are going to work on it, change the part, or get it serviced before the breakdown happens. Presently, we work on a reactive based system in which after something happens, we give a reaction by changing something or by fixing it. But what if you could know what is about to break before it is breaking? So that is one way it can help you a lot. Then there are chances, like every year we read on newspapers, TVs, magazines, that there was this accident of X factory. There was a fire blast. There was the boilers were bursting. So there are a lot of things that we see every day. Maybe due to a small electrical spark, something happens. So all these things can be mitigated by a huge amount, not 100%, by a huge amount. We can manage a catastrophe from occurring. Maybe your material is getting lost, or you're getting, due to higher temperature, you are losing on money, the batch is being rejected. So there are a lot of things which can be mitigated easily. Then you can also increase the lifespan of your electrical equipment. So now we've all heard is something that well-oiled car will last you longer. Same way it goes with your electrical equipment. Now, if your electrical equipment is running on a bad or faulty quality of your power, or your machines are not working in a balanced form, then they are prone to fail earlier and not give you the desired life that it was meant for, or what you had accounted for. And the most important point is, if you are able to measure what is your cost per piece every time, what is your cost per kg, what is the cost per hour, then you are bound to reduce it. Because still you don't know what is happening, then there's no chance of improvement. But now once you know, okay, every hour I'm burning in 1000 units of electricity, or my compressor is running dry, my pumps are running dry for 2 hours, 3 hours, then you are bound to work on it and improve it. And that is where we come into place. Now मोटा मोटा देखने जाए तो इलेक्ट्रिक एनर्जी को हम दो हिस्सों में बांट सकते हैं, एक है क्वांटिटी और एक है क्वालिटी. Okay, so quality will be for this example is specifically for electricity that we use. So electricity quality parts are 6 parts that are there, which are very critical. One is the voltage. What is the voltage that you're receiving? Is it balanced? What is it, high? Is it low? What is the voltage? Power factor. How good, how bad is the power factor? So I think with the power factor, I'll just give explanation. Voltage, I don't think I need to explain. Power factor, if it is not maintained well, there are two problems that occur. One is you face higher power cost. Second is your assets don't work at the efficiency. Your cables start getting heated. The cable capacity reduces. Motors that are running, they will also reduce their efficiency. So the power factor is the single-handedly biggest key factor that will help you increase your quality of energy and reduce your cost. Third is harmonics. Harmonics are something which it's a relatively new concept which is coming to India since last 5 10 years. We've seen harmonics. Harmonics can be termed as a virus of your electrical energy system. So harmonics are one thing that can work, move forward and backward. It's a virus that will heat up your motors. It will reduce the efficiency of your motors. It can cause electrical damage. So let's say you got a lot of VFDs in your plant, and there are also some servo motors in the plant. Then the chances of those servos failing will become higher if the harmonics are very high. So if harmonics are high, the motors will also wear down fast. Electrical components will also wear down very fast. And in certain cases, we have seen in a lot of cases, not certain, that a lot of times electrical equipments like servo sets, PLCs tend to fail up abnormally. Anytime they can fail. And we've seen a lot of failures due to harmonics. Now, what happens is that once they fail, then only you'll see my harmonics are high, now I need to work on it. But prevention is better than cure. So that is what we help you. Then the current quality, is it in balance? If there is any problem with the balance, if there are harmonics in the current also, we will be able to measure it and monitor it so that we can check. Then the earth quality. This is something that everyone is familiar with very well, but we tend to neglect it a lot of times. If the earth is high, if the resistance is not proper, then you are again chance of damaging your electrical equipments. In a lot of cases in monsoon times, there are very high chances of your equipment failing due to bad earth or bad neutral. Now, if your neutral is bad, if neutral quality is not good, then again your power consumption will be higher than what it should be, because you're wasting a lot of voltages and current. So that is also there. So these are quality parameters which we need to monitor on daily basis to be sure that everything is working well. And then the second part is quantity. What is the quantity of power used? So for this example, we will take a 2-inch pipeline of water. Okay. So it's not a very scientific, but it's just to give you an estimation of how everything is. So now that 2-inch pipeline is the demand that you've taken from your respective electricity board, PGVCL, UGVCL, that I will consume maximum of 1000 kVA. That is my demand. So that is the pipe size. So it can be 1 inch, 2 inch, that is 1000, 2000 kVA. Then that is current, that is rate flow. How much of water is passing through every second, every hour from that pipe. That is your kVA. That is your current in ampere. So that is the current that is flowing in. Then third is units consumed. That is how much liters of water you've accumulated or you've used. That will be your units consumed. So these will matter on how much power you're using and how frequently you're using. And quality will again determine, if the quality is good, the quantity will be lesser. If quality is not good, the quantity will be higher. It's a very simple formula. So if your voltages will go high, then your current will go down. But they should not be very low or nor should be very high. If they are very high, then your system will, your motors will fail, your temperature sensor might get, your heaters will fail. These things are there. So now I'll come to very practical problems that every industry faces. Some industries will face more problems, some will face less problems, but these are overall the major problems that are faced in most companies that we've visited, we've audited, we've provided our services in. So power PF problems. So power factor is not maintained in a lot of companies. Now, let's say if you talk about a company that is using furnaces. So in furnaces, there'll be reactive load will be on leading side. So you need to work on your inductive load. And due to that, power factor is on negative side. But now let's say if your company is into textile, if it is into FMCG, then you are using a lot of inductive load. So inductive load is higher and your reactive load is lesser. So inductive is leading. In that case, again your PF goes down. So now when PF is down, the electricity board will charge you high amounts of they'll charge you penalty. And if your PF is good, they will reward you with they will give you a reward. So it's a win-win situation for both of you. If your PF is good, you also get rewards. Your life of your assets will also increase. Then sometimes if your inductive and reactive loads, your capacitors, your PF bank is okay, but after due course of time, we see that capacitors that are used for maintaining the power factor are wearing down, and then they are not replaced timely. So that also causes a lot of PF problems which are not seen in early time. So once the company will start facing this thing, fines from the electricity board, then only capacitors are changed. So that is also one big problem. And due to your PF not being correct, your energy consumption will also be higher, because now it will need more ampere to work on the same load. So now let's say if you've got 100 HP motor which needs to give an X amount of torque, now to deliver that it might need 120 amperes of current. But now if the PF is bad, it might need 125 amperes of current to deliver the same torque. And that is only up to a certain extent. Now let's say if you need higher torque from the same motor, then if your PF is bad, you might not even get that amount of torque. So PF is one of the biggest reasons in which you can improve on and increase your life of assets and reduce your power consumption. Then second would be inefficient transformers, which come into place after 5 years, 10 years down the line, which are into losses due to heating of the transformer. Maybe the old DC is not working, the taps are not being changed, so you are getting low voltage, it's not able to transform voltage correctly, and your system is working on low voltage, or maybe it's working on higher voltage, due to which everything will be go haywire. So if there is low voltage, then your systems are prone to heating. If there's high voltage, then also they're prone to heating and not delivering the same amount of output that they should. So transformer monitoring is very important, because if transformer is not working well, then everything down the line is not working well. So and in some cases we also see that transformers can blast if their temperature is not monitored properly, if their oil level is going down and nobody's topping up the oil, or oil is not cleaned regularly. So maintenance of transformer is very much important, but it is missed out a lot of times in a lot of companies. So managing your transformer well is one of the most critical thing, because that's the first point of your power delivery. Then there is current imbalance. So when you see your current, you all would have seen that your R, Y, and B, all of them are not equal. The current is not equal. Okay, which is bound to happen in any case. But now, what is the variation? Is it of 1 ampere, 2 ampere, 3 amperes? Okay. If it is near to 2%, then it's fine. But if it's more than 2%, then again your assets are at loss. So now let's say I have a 3-phase motor. Again, I'll take the example of 100 HP motor. So now my 100 HP motor, it's consuming 120 currents on R phase, 110 current on Y phase, and 120 on B phase. So now you can imagine that these two phases are taking current properly, but my Y phase is not taking current properly. So in near future, you know what is going to happen? The motor is going to fail. Why? Because there was some problem with the motor. Now, how would I know if I'm monitoring the current imbalance? I'll be able to know that something is going wrong before it will fail. I'll know it. But now, if I'm not monitoring it, I won't know. Then, due to this problem, what will happen now? Let's say the inverse scenario. We've got two phases that are taking 120 amperes, and third phase which is taking 135 amperes. So it's 15 amperes higher. So, but my cables which are laid out to the motor were designed for only 125 amperes. So now it is going above the limit. So now my cables will also start heating. They, with heat, there will be a lot of resistance. And again, I'm wasting my energy in generating heat and reducing the efficiency of the motor. And over due course of time, if it is higher current on one phase, then also the motor is about to fail. So with this case, by monitoring current imbalance, you will be able to measure when things are able going to fail. And in a lot of companies, when they're designed, when they're operational for the first time, everything is working fine. But after a period of 5 years, 10 years, when you've done expansion, then the imbalance will increase because you've not taken single phase loads into consideration, and sometimes growth is done haphazardly, and due to which current imbalance will increase, which will again result in you paying higher amounts of electricity due to current imbalance. I hope I'm going at the right speed. If there is any suggestion, please do let me know. Now I'll come to voltage imbalance. This is one of the most critical thing that can happen is voltage imbalance, because voltage imbalance can also cause current imbalance. So if your voltage is not balanced, then your current will also not be balanced, and due to which again I've mentioned what all problems can happen. And due to voltage imbalance, some single phase this thing appliances or instruments can also fail. So voltage balance is the most important thing, because it there's a lot of things going down the line because of voltage. Then higher demand utilization is there evidently, but not in all industries. So we've seen that in industries where you got a cut to cut demand, in which let's say your demand is 1000 kVA and your connected load is 1200 kVA. So it's working on a cut to cut, in which you have to make sure that all your assets are not starting at time, or if your transformer capacity is not increasing the demand that is being utilized. So if your demand is being utilized, then the transformer capacity, then there are chances of failure. If your demand is increasing, then your contract demand, then you will again get fines and duties. So that is also one way in which you can reduce your electricity bill. If you know that you're already on a higher demand side, then with the help of management of correctly timing when to start the assets, you can reduce on your uh, fines, not just by increasing your demand, but by installing management solutions. Then low voltage is also a big problem that we've seen in a lot of industries. By low voltage and high voltage both are included. So low voltages can occur because of sometimes long length of cables. So if a cable is very long and the size of the cable is adequate, but not on a higher side, then the voltage, there will be a voltage drop. And with voltage drop, you will be consuming more current and more power just because of voltage drop. So again, if it is managed well, if voltage is managed well, monitor well, then there's chance of reducing your power cost by 0.5%. Then PF, because low, but like one of the reasons for low voltage is also if your power factor is not maintained well. So I'll give you a classic example. In your office, when you take next time when you take printout on a laser printer, just see the lights which are there. So there's 90% chances that your lights will flicker when you're printing through laser printer. The reason is because laser printer will consume a lot of power at the same time, and if your cable size is not adequate or your power factor is not well, then it will suck down all the voltage that is there, and the light will not get the light that the bulbs will not get enough voltage to operate well, and they will flicker. Now just imagine your small light bulb, your tube light flickering. Now imagine what will happen to the big machines, the big PLCs that are running on this system. Now that small flicker can cause your PLC to fail. It can cause the VFDs to fail. It can cause some sensors to malfunction. So it's a very small thing with a very big footprint. Okay, so it's like एक छोटी सी सुई है जो अंदर घुसेगी तो बहुत खून निकल जाएगा. So it's a very small thing, but it can lead to high costing and lead to failures. Now this is very important: high current, high harmonics, and frequent trippings. This is the last slide on the mesh management. High current. Now, like when you go to doctor, he will measure your BP, and he'll tell you if it's okay or not. Same way, every motor, every temperature heater is designed, every asset is designed to work at certain current, at certain power consumption level. But what happens is that over a period of time, we know that my motor is about to run at 100 amperes, but over a period of time, or my temperature is about to work at 20 amperes. But over a period of time, it is taking higher ampere, higher current, higher ampere, higher current. Now, every few months, your operator will start getting used to the new baseline. Now, this is very important. The baseline is an judgment that an operator or supervisor will take care if it is working well or not. So, I bought this machine today. It's taking 100 current, 100 amperes. It's okay. After 6 months, it is taking 105. So now I won't think 105 is high, but I will create 105 as my new baseline. कि हाँ चलो ठीक है 105 ही तो ले रहा है चलेगा. और 6 महीने चलते हैं 110 एम्पेयर हो गया. देन आई विल लाइक हाँ चलो 110 ही हो रहा है चलेगा. बट 110 अभी 10% बढ़ गया है. ओके, आपका 100 एम्पेयर से 10% बढ़ गया 110. चलो ठीक है यार चलेगा यार. फिर 115 हो गया. अभी 15% बढ़ गया है. अभी ये 5%, 10%, 15% क्या है? तो ये आपका पावर कंजम्पशन का कॉस्ट है जो बढ़ गया है, बट किसी ने नोटिस नहीं किया क्योंकि ये छोटा है. हम सोचते हैं यार छोटे छोटे है क्या होगा, थोड़ा ही ज्यादा लेना ना क्या हो रहा है, पर सब बराबर ही तो है. नहीं, बराबर नहीं है. क्यों? क्योंकि हम सबने सुना है कि गुजराती में कहावत है कि टीपे टीपे सरोवर भराई. वही. So like every drop can lead to filling of the whole lake. So sorry, I won't be able to explain, but so same way every small increase in 1% is leading to massive increase on your power bill. And not just that, it is also getting inefficient. आपका ज्यादा पावर ले रहा है तो उसका मतलब है आपका मोटर इनएफिशिएंट हो रहा है, या आपका बेरिंग वीक हो रहा है, आपने ग्रीसिंग ठीक से नहीं किया, आपकी मशीन में कुछ टाइट हो गया है ज्यादा, या आपका मशीन में कुछ प्रॉब्लम हो गया है. तो ये बहुत सारे पैरामीटर्स होते हैं जिसका रूट कॉज एनालिसिस करना पड़ता है. बट वो तभी हम करेंगे जब हम पता चलेगा कि यार ये मेरे बेसलाइन से 5% बढ़ गया है. ठीक है. और कहीं कहीं हमने देखा है कि लो वोल्टेज की वजह से भी हायर करंट लेता है. और जैसे करंट ज्यादा होगा वैसे ही हीटिंग ज्यादा होगा आपके सेट में, आपके मशीन में. और आपका मशीन कूल डाउन उतना होगा कि जितना उसको डिजाइन किया है. जब ज्यादा गर्म हो रहा है तो पावर कंजम्पशन भी बढ़ रहा है और वो आपका मशीन खराब हो रहा है. द वाइंडिंग इज गेटिंग वीकर. सो जैसे वाइंडिंग हीट होगा, खराब वीक होगा, वैसे उसका एफिशिएंसी कम होता जाएगा. और एनर्जी में सारी चीज एक गोल चक्कर की तरह है कि एक बार अगर कुछ भी दिक्कत हो गई ना तो घूम 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 के सब बिगाड़ता जाएगा. देन हार्मोनिक्स, मैंने जैसे बताया कि हार्मोनिक्स कैन बी ह्यूज problem in a lot of industries where VFDs are used, servos are used. So harmonics can cause a lot of problems. So some of the problems that it can cause is cables running hot for no reason. Even if your cable is at a lower current, then also it will get hot. Then it can shut down your ICs. In your PLCs, in your servo controllers, there are small ICs which are working in a VFDs. Now it can cause the ICs to malfunction. Now with the malfunction, your system can fail, or it can also create an accident. Then frequent trippings. So this is not a big problem, as in terms of power costing, it can be, but in terms of downtime, this is a big problem. If your system is getting tripped frequently, it can be due to MCCB rating getting smaller because you keep on expanding and you don't like increase your MCCB is one of the last thing that you will think of doing. कि हाँ यार चलो एमसीबी तो बदलनी होगी, ऐसा तो कोई सोचता ही नहीं है, 2 मशीन और लगा दिए, बट एमसीबी कौन बदलाएगा? तो उसकी वजह से देयर आर टाइम्स व्हेन यू, और एमसीबी also has got a life, so if that life is about to get over, then also it will trip occasionally. Then there are chances of earth leakage, which we can mitigate it, and because of earth leakage we can get trippings frequently. So these are some of the core reasons why energy is mismanaged in a lot of places. And I think if you are able to work on these solutions, you'll be able to save a lot in terms of increasing your life of assets and save on your power bills also. So now when you ask कि चलो सागर ये सब तो ठीक है, बट इसका फायदा क्या होगा? तो मैनेजमेंट का फायदा ये होगा कि पहले तो मैंने जो भी मिसमैनेज पार्ट्स है वो जैसे मैनेज होने लगेंगे, वैसे ही आपको आपकी एसेट की एफिशिएंसी बढ़ने लगेगी, ठीक है? सो फॉर दैट वी हैव बिल्ट इन अ लॉट ऑफ केपीआईज दैट वी डिड्यूस फ्रॉम द डेटा वी गेट. सो आपका एनर्जी का ये सब डेटा हो गया, वोल्टेज, हार्मोनिक्स, पावर फैक्टर, करंट, ये सब डेटा मिला के हम इसमें से केपीआईज बना के हम देते हैं हमारे क्लाइंट्स को. जैसे कि टाइम ऑफ यूज, it's a very small thing, but it can work wonders. So time of use is out of 24 hours, how many hours your machine was turned on, and how many hours was it working on production mode, how many hours was it working on efficiency. That is what we gave you. You want your factory to run at speed of 1000 units per hour. So how many hours were there when it was working on high productivity? How many hours were there when your machine was sitting idle? How many hours was there when machine was just lying off? So that is one KPI that we reduce, which a lot of customers have loved it, because it will give you key where you can improvise, where you can improve your efficiency, where you can increase your productivity. Sometimes you may think, yeah, I need 2 machines, but then I need to add 2 new machines. But once you monitor कि हाँ यार मेरा 6 घंटे 8 घंटे की शिफ्ट में 2 घंटे मेरा मशीन कम प्रोडक्टिविटी पे चलता है, then you can increase at least 20% of your production just by that. Then asset efficiency over time. So now we help you establish a baseline. From baseline, how efficient your machine is, we'll help you monitor. But now if you already have 5-year-old machines, 10-year-old machines, then we can talk to the OEMs and get the new baselines or get the old baseline, or we can also recalculate the baselines which the machine was supposed to work, and how much of deviation it is there from that baseline. Then we can also give cost of unit per production. So now मेरा एक मोबाइल बनाने का कॉस्ट कितना जा रहा है, एक लैपटॉप बनाने का कॉस्ट कितना जा रहा है, मेरा 1000 मीटर ज्ञान है उसको प्रोसेस करने में कितना पावर का कॉस्ट जा रहा है. सो आई कैन हैव दैट विथ Sankey diagram or Pareto chart. So now let's say I'm making 1000 kilometers of thread. So in that I'll be using water, I'll be using power, I'll be using compressed air. Okay, and then there are 3 other machines that I'll be using. So now which machine is taking how much of power? So my compressors are amounting for 30% of power consumption. My pumps are using 5% of the energy. Machine motors are taking 10%. So that way I can have an analysis of how much power is being utilized where. Then energy health. What is the health of the energy that we can deduce through a small number, that my energy health is at 80%, 70%, 100%, 90%. So which you don't need to look into कि मेरा पीएफ बराबर है, वोल्टेज बराबर है. आपको सिर्फ यही देखना होगा कि आपका 90% ऊपर है कि नहीं है. Then breakdown of costing, as I mentioned. So this can be worked on anything. Now let's say you want to measure आपका स्पिनिंग मशीन कितना चल रहा है, आपका पावर प्रेस कितना चल रहा है, प्रेस में आपका पावर कंजम्पशन कितना हो, what is the pressure it is delivering, how many hours your compressor is online, pumps, everything. So all the assets that can be individually also monitored and managed, and clubbing it also can be done. So I'll come to the benefits that we've delivered. I think everyone was pretty excited of the benefits that you can give or you can get. So There are wide range of benefits, but I have chosen to speak only of these five. So you can reduce your power cost by 1.5%. And this is a real figure. So we've helped companies save more than that also. But this is one of the most minimal power consumption that you can save just by tweaking few things. Then मैंने मेंशन कि आपका एसेट का प्रोडक्टिविटी कितना है, तो वो प्रोडक्टिविटी बढ़ाने से हम 17% तक एफिशिएंसी हम इंक्रीज करते हैं ऑफ द एसेट्स. और एफिशिएंसी आपका मोटर का एफिशिएंसी हो गया, आपका हीटर का एफिशिएंसी हो गया, वो भी हम बढ़ा सकते हैं अप टू 10%, अप टू 15% we can increase, and we have increased. These are facts. Then improved planning and cost calculation. Now let's say you, while installing the machine, you thought कि हाँ यार मेरा पावर कंजम्पशन इतना हो गया, ये होता है, तो मेरा पर पीस मेरा 10 रुपए में बढ़ता है और मैं इसको 30 रुपए में बेच रहा हूँ. So 10 रुपए में you integrated 3 rupees as your power cost, but over period of time your power cost has increased from 3 rupees to 6 rupees or 5 rupees. So that you not calculated. हाँ कि यार ये भी बढ़ के है. So that way you can have a proper cost calculation in real time. So you know कि what is the power cost every day, every shift, every week, every month. Then we've helped a lot of processes from failing and machines from failing. We helped more than 50, 100 motors from failing and causing damages of, I don't know how much, but it's a huge amount, because once a motor fails, you have to give 5 to 10 days of time for the rewinding. Rewinding cost hoga, the rewinding quality is not as good as the OEM winding. So all these things are there. Then in some certain case we have seen key, just because in one case we had seen key that temperature sensor probe had failed and still the heater was turning, it was on. And the process was that from ambient temperature, that is 32 degrees to 100 degrees, it will take certain amount of units. So 1000 unit लगते हैं, for example, to reach to that level, and it should reach that level in 3 hours. That's the set point that they have. So that is the baseline that we've established for that company. So that is 3 hours and 1000 units or 100 units. But now if that baseline is being changed, then we can predict that something is not working as desired. So then in that case we came to know that power consumption itna ho raha hai, but temperature बढ़ नहीं रहा है. So we just sent out an alert कि there is something wrong on this machine, and the supervisor quickly ran and checked कि since last 1 hour my temperature is not increasing but my power is going up. So he was able to save that whole batch of 10 lakh rupees from failing. If he would have waited like for 1 more hour or 2 hours, तो पूरा पिघल जाता, सब पिघल जाता, पैसा भी पिघल जाता. So we've helped that way. So this is just one of the things. Then in one case, what we've done, I'll just show you. It's better I show you in live. So now in the data access. So how do you access the data that you are acquiring? So because you are acquiring a lot of data in real time, then you obviously want to access it in a way that is very efficient and which is very handy. So for that, the dashboards can be put on your laptop, your computer, or it can also be put on big Android display. So in recent times we've seen that 32-inch 50-inch TVs have become very cost effective. So you can put an TV on your shop floor and you can display your power consumption data, your efficiency data, your voltage imbalance, and you can show that data to the clients, to your supervisors. And when there is something wrong, you can get it fixed instantly. Sorry. Then there are reports. So reports will be your power consumption, your efficiency, the losses in daily format, weekly format, monthly format. Then if you want there's some person who wants to see a very detailed version, then we can also give a very detailed hourly report. What is the actual imbalance? Which cost center is giving you higher imbalance? Where the harmonics are being generated? we can give you a detailed. Or is there somebody like me who just wants to go through the reports every day in the morning or maybe at the night? Then you can also have summarized report also. Both are possible. So your reports will have everything: power consumption, power factor, your maximum demand, which cost center is taking higher amount of power, everything. Then when things are not going the way that they should, that is when we detect an anomaly, alerts can be sent. Alerts can be sent on mobile application, on Android phone, Apple iPhone, or through Telegram alerts we can send. Or if you want them to be sent on emails, then that can also be done. Let's say your power factor is going down, we'll warn you. If your voltage imbalance is going higher, we'll warn you. If your power consumption is going out, so now let's say every year your machine should not take less more than 600 units. But if it's going above that, we'll warn you. So that way, your logic, that will be our anomaly. So whatever your logic is, we can give you the anomaly detection on that. If you don't, if you want us to suggest, we have got numerous suggestions we can give after an audit. Then the new one and speaker to be installed. No, so now let's say you say कि dashboard wireless ये सब तो ठीक है, but my shop floor is very noisy, or my operators supervisor are very busy. They really don't want, they don't really have time keep checking what is happening. In that case, we can also install big loudspeakers. So you got Ahuja loudspeakers. We can install those loudspeakers and we can announce the alert in local language. So let's say we can have an alert like this in Gujarati. બાર નંબરની ફેરનેસમાં ટેમ્પરેચર વધી ગયું છે, પ્લીઝ બંધ કરો. અથવા વોલ્ટેજ ઘટી રહ્યા છે અને પાવર વધી રહ્યો છે, તો ચકાસો. So that way you can have alerts in any language you want, auditory alerts, which will be sent to everyone, which everyone can hear and act upon. Or now let's say, yeah, in a lot of cases we've seen this beautiful thing, like it's a very sad thing, but it's something very common in a lot of industries. When power will go out, somebody will turn on the generator, but when power will come, generator will be switched off after half an hour, 15 minutes, sometimes even 2 hours. So in that case, we've installed this solution in a lot of places and people have got very happy. Okay, we just notify कि power has arrived, that's it. And that has saved a lot of diesel also. And so it's a very small thing that we do, but the impact is very big. So alerts speak for themselves, literally. Then you've got predictive maintenance, that data. So now when you're generating a lot of data, you can use that data and go from reactive maintenance to predictive maintenance. कि now कब आपको bearing change करना है, आपको greasing कब करना है, आपका overhauling. Now you said कि मेरा मोटर 1000 घंटे चलता है, फिर उसका overhauling मुझे करना है, कि आपका spindle का life इतना है, मेरा tool का life इतना है, कि ये है वो है. So all these things can be set as per the formula that you have, the condition you have, and whenever that condition is triggered, we will tell you कि now it is time to do maintenance, to change your bearing, to do this, and we will also tell you कि this is the SOP that is needs to be followed. So this is for data access. Now it comes for time from energy meet, like how it works. I'll just be very brief. So what we do is we can connect any type of energy meter which is not an RS485 port to the IoT gateway. Okay. Now we can connect multiple meters to one gateway. Then the gateway will process the data and send the data to the cloud using Wi-Fi or 4G technology. And then that data will be accessible to you on these platforms. So I'll just now start with the live demo. Is my screen visible, Himanshu ji?
Yes, Agar, it's visible.
Perfect. So now this is an login to one of our clients' system, which we have taken permission from. So this client has got a pulverizing system in which they pulverize a lot of material and then they sieve it, screen it, and sell it off. Okay. So their biggest pain point when they approached us was that कि સાગરભાઈ મારા મશીનમાં પ્રોડક્શન ઓછું નીકળતું છે ઘણી વાર અને મને ખબર નથી પડતી. So what we did was we connected their machines to our system. So they've got 60 HP mill, 75 HP mill, 75
Again,
HP
some of
mill.
them don't know even Gujarati, so you can keep in Hindi and English.
Okay, okay. So so these are now grinding mills. They've got 3 grinding mills and few blowers that they have. So what their biggest problem was that they were not getting the right amount of production every day. So their target, their machine was capable of doing 8 to 9,000 kgs per day, but they were only getting 3 to 4,000 kgs per day. Okay. So then we thought of the solution. We prepared a BUM, we sent the quotation, and they approved it. And after installation, what our findings were, I'll just show you. So now we've seen that their production did not start on time. That is one biggest thing that we saw, was that production didn't start on time and it ended earlier. So then in a lot of times the material was not being fed properly. So now this mill is being, the average current over here is 58 amperes and the power it is consumed is 178 units, and it is on since 6.5 hours and idle time was 2 hours. So all this data we are getting from the energy meter. And what is the current? It is at optimal level. And then if there is any tripping, we'll come to know here. Okay. So we, as you can see over here, a lot of alerts have been triggered. So at 4:48 there was an alert, 4:58 there was an alert that there was low production detected. So now every time this alert is there, we put in a siren like the ambulance siren we put in, that will turn on so that operator will know that I need to start production. So you can see there was alert at 4:50. Right now it's 4:55. Now you can see that current has again come up. So when operators will start getting lazy, my system will tell them that we need to work. So they'll start again working properly. So every time the machine was on, they got an alert. So all this, there are lots of alerts. Then we provide the reports. First, I'll just show the live data. So in this case, we are taking this second, how much power consumption, the current, average 3-phase voltage, current on all the other sides, the imbalance of current. The imbalance over here is 2.65, which is okay. Then how many times the machine was turned on? So it was turned on 6 times today, and since last it was turned on, it has been working since 2 hours, and total runtime was 6.5 hours today. So power factor again over here, we can see it's very weak over here. It's 0.86, wherein it should be 0.9 or 0.99. It should be. So we can see power. It is over here to check. Power factor range is to check. So I'll just show you one report. So this is a report that our client gets every day on his mail. So what is the available time on the mill? What is the idle time? What is the productive time? So we can see that available time. So I've selected 18th 12 a.m. and 19th 8 a.m. So available time was this much, the productive time was this much, and idle time was this much. Power consumption was 1600 rupees, 800 rupees. This is when the machine was turned on. This is in the morning when it was turned on, night, then morning. So this way, this is the power consumption trend. So it was at 60 to 70 amperes, it was running well. So we can see that earlier this client had the machine was running at 40 to 60 amperes. Now it is working stably on this chart. So you can see this is due to our intervention and our solution that they've been able to increase their productivity. So now over here on this mini dashboard, you can see which mill is taking how much power and what is the status. So same way, I'll just show you another screen. Just a second. So here in the screen, we can see that there are 23 assets over here that are there, out of which 18 assets are online, 5 assets are offline. We can see what is the power consumption of the factory, that is 6,800 units. What is the kVH, which is 6,700. What are the harmonics? We can see over here it's 7% of voltage harmonics. Then current harmonics has 12%. So now voltage harmonics should not be greater than 5%, and current harmonics should not be greater than 15%. So overall, this is not very healthy, but it's healthy. Harmonics are healthy. We can see how much power is being consumed: 827 kilowatts, 830 kVA, and the power factor is 999,999. That is the best power factor you can have. Over here we can see this is the live current that is there, 163 1163 amperes. So that is there. Then you can see which assets are offline. So I know that this ASD, this compressor is offline, LG compressor is offline. So which machine has consumed how much power? So this machine has consumed 9 units of power. This compressor has utilized 214 units of power, 279. So now we can dig deep into it. So I'll just show you one dashboard that we have created for the customer. So in here, this is a dashboard that you can have as a hand-on dashboard, in which you can see कि आपका power कितना हो रहा है. So 6,000. This is the power consumption. This is the max demand which is being utilized. This is the voltage which is there. So you know what is the max voltage, minimum voltage. This is the current. It's stable. We can see that there are no spikes in the current. So spikes in current or spikes in voltage can create big problems. So the voltage deviation is only 3 volts, which is very good. Now current deviation is on higher side. You can see it's 56 voltage. So it's 87 voltage, sorry. So it's very high. Power factor is 0.99, which is again good. Harmonics are again higher, but it's okay. Then you can see unit wise power consumption of each unit. Now this machine is online. It's green because it's online. This is white because it's offline. So all the units that are offline are white. All the units which are online are green. So on one view, you can know how many assets of yours are online and offline. Then what is the power consumption trend in the last 24 hours, you can see over here, my trend is almost the same, which so everything is working healthy and well. You can see power consumption trend heat through a heat map of all the machines, critical machines you can see. So I know that this Barmak machine is utilizing the most power. Then Alidra is there. Then these two machines. These two machines are offline. I can see. I can see 86% of our machines are online. Out of 7 machines, 6 are online, and my compressors and utilities are 60% of online. I can see 6 are online out of 10. So this is the dashboard that is there. And then if there is any alert, you can see if my pressure is going down, if my ACB is tripping, my VCB is tripping, or if the oil temperature of my transformer is going high, then we can send an alert. If the transformer winding temperature is going high, we will send an alert because that's a very critical scene scenario. So this is one dashboard that we have for this customer. Then these are the signatures of the current. This is a report of current signature. So we can see everything is okay, but there are 1, 2, 3, 4 spikes. So now I need to see if there was any activity that was there uh, for the spikes to occur. Otherwise, everything was okay, but there was loss of production between 7:30, 8:30 p.m. and morning 4 to 5 in morning time. Then we can see I key amperes are not consistent like they are in this machine. So I need to see why the current consumption is not stable, and I need to work on the reason for it. Then I can see my compressor was very much stable. This ASB40 was very much stable. This one again, there are a lot of spikes going on. So I need to see what is the reason. And I can do a root cause analysis from this data itself why the problem was there. We can again correlate this data with voltage, with pressure of the compressor, with temperature of the motors, temperature of the machines. Same way, all these temperature current trends are there. Then we also have the whole factory overview of energy consumption. So we acquire data at very high speeds. So we acquire 125 data points per second. So we can see the energy utilization. This is the trend analysis, which is just a second. So this is the report for factory energy report of yesterday. So the demand utilization was 69%. Time of use was 13 hours. Power consumption was 11,000 units. Maximum demand was 862. If there was any chances in which there was over demand, I'll know how much over demand did I consume. Maximum current, like average current, power utilization was 36%. Power cost was 88,000 rupees. Then per unit, how much time of use was there? Maximum current, power cost, and power cost over here. So 8,000 rupees here, 100 rupees here, 3,000 here, 22,000 here. So that way I've got for everything. Then the voltage deviation which was there, current deviation, power factor. So I can see at night time my power factor was low. Otherwise it was all good. The harmonics we are able to see over here. What is the level of harmonics over here? Now this is the trend analysis, energy trend for 1 week. So in 1 week, my demand utilization has been 67%. Max demand is here. Power consumption for the whole week was 18,000. So my power cost was 1,46,000 rupees. Maximum voltage harmonics 9.3 percentage. Current harmonics for 29. So this is alarming figure over here. This 29% should not be there. Then my KW is 18,000 units, 16,000, 1,100. This is offline. 8,500, 12,700, 17,600. Then KW is trend over here, we can see. Then KVA, then utilization, like which machine utilize how much power. So 36%. So now maximum was my Burma. It consumed this much of power. So 3,000 units were consumed just by this machine. Okay. So which is around 45% of my power was consumed. So 36% over here was consumed by Burma. Then Alidra is the next biggest power consumption over here. So I can see which machines are consuming more power. And now once I see this report every few days, I will know where there is a problem. Same way with other units, compressors, power factor. So you can see over here it is lagging. Over here you can see it's leading. So it's very good. Voltage analysis is also here. Then this is the current analysis that we have. This is again power consumption table of the whole week. On which day, which unit consumed how much power. So this is for this one demo I've shown you. I'll just show you one more. And do we have time, Himanshuji, to show one more demo?
Yeah, I think if it adds some significant insight, you can have. Otherwise, we have just 5 minutes left to wrap up the session, and otherwise we can go for Q&A.
Okay, perfect. I'll just show one more demo. Okay.
Yep. If it has got similar features, then you can skip.
No, this will be completely different. Is it visible? Is my screen visible, Himanshuji?
Yeah, it's visible.
Okay. So now this is one of the dashboards for one of our clients who has got a wire drawing machine. Okay. So now this is dashboard that they utilize on every machine. So they've got few machines that are connected to our system, and for every machine they have created this kind of dashboard in which they know what is happening on the machine anytime, every time. Okay. So what is the name of the recipe that is into production? Who is the operator on that machine? So all this data that I'm showing you, it's all automated data. There's no manual entry being done. So we just provide a barcode reader to the client and or HMI, and from that we get the data. Then what is the state of the production machine? It is in production. What is available time? What was the loading time, operating time, net operating time, availability 96%, performance was 76%, quality 100%. So the OE of this machine is 72%. Then time spent for setup was 23 minutes, minus stoppages were 58 minutes. Today there were no breakdowns, so 0 minutes. Then there was some other downtime. Then what is the machine speed? I think it's offline again right now. It might restart in this. So we've shown standard speed over here. and what is the actual speed, it will be shown over here. What is the power consumption, we've shown like how much power it is consuming. Then current, we can see its machine is offline, so once the machine starts, it will show. Then what is the production? So 6,700 kgs were produced. So what is the size of wire in the machine? The kilometers of wire, kilowatt hours per kg. This is cost of power per kg. So 0.32 paise is the costing. This is very important over here. Yeah. So this is per kg they are spending 0.32 paise in power. So what is the production target? So this is the production that they've done, and the target for this day should be 7,300 or 7,400 kgs. So this is one more dashboard. So we've got a lot more dashboards which show different type of data, which are tailor-made to clients' requirements. Yeah, I think we can take two questions.
Thanks, Sagar. Thanks for the wonderful presentation. Do we have any queries? Then we can take before going forward for the session. Any queries? Ashish ji, Akash ji, Ankit ji.
No. No, sir. No, sir. Everything is clear.
Okay.
Hello.
Yeah.
Yeah, Himansu, Minesh here from
Yeah.
CLM.
Hi.
Hi,
Manish ji.
hi. Yeah, first of all, thank you, Sagarji, for sharing so much fantastic presentation. See, I have one question. See, we are also reviewing that production monitoring system, right? That is basically the output of the machine, how machine is behaving, number of parts that has been produced by the machine. And this is regarding something machine means energy consumed by the machine, right? It's a real-time data. Okay, so I just have to ask one thing that if one machine is consuming more power in terms of either voltage or current, I'm not the expert of electrical factors, but still, if one machine is consuming more power, that doesn't mean okay, there is something wrong in the machine because that time machine may be like producing or maybe the MRR of that machine might be high. So that's why that is the reason that this machine is consuming more power. So how we can conclude means whether the machine is self having some problem or machine is giving output and that's why the power consumption is high, energy consumption is high.
Correct. So you pointed out very well. So in the last dashboard I showed you figure of 0.32 paise per kg, right? So now baseline, let's consider that this is my baseline. So now if my machine is consuming 0.4 paise per kg, then obviously there is something wrong.
Okay. So
that way, that is
we have to compare the real-time data with the standards data, means what standard says, right? And if anything is deviated from the standard, that we can say whether anything is wrong on the machine, right? So based on the standard, we can okay, fine. And one more thing, see, we have a SAP here. So sometimes what happens, we observe some error while entering something or something. Then if I like double click on that error, that SAP will give the diagnosis and the remedies. So if here any deviation is there, maybe power consumption is more something. So do we have any feature like if I double click or somewhere from some report, I can get some remedies because that is important. Monitoring is important, but the action that we have to take is very, very, very much important. So if anybody can like click on that data and can get some kind of remedies, these steps you have to take. So is there any feature like that in this company?
So I'll just share my screen again. I'll just show you the maintenance module. So now let's say, for remedies, now let's say there are two patients who have high blood pressure. The remedies for both of them would be very different. Okay, so diagnosis for them will be very much different, though they have the same problem. So let's say your machine is taking higher current, both there are numerous reasons which can be there. So for that, we can have a condition-based predictive maintenance system. So now let's say we can predict, okay, let's say if your machine is ABC is your machine name, okay, we can set an alert, okay, if there is something like this in this machine. So now let's say if this is the machine and here if PF is getting higher, then I can set key if PF is going higher than 1.02, okay, then what would happen? So then I will put few things over here which need to be checked over here. So now I'll put an maintenance SOP over here. I'll just come to, so now maintenance SOP is what I need to check. So now let's say if my baseline is going higher or my PF is going high, I'll put an instruction list key, check bearing, okay, check connections to terminal, check greasing. So now your maintenance person will always know okay, what can go wrong. So once you talk to him कि भाई अगर ये ऐसा हो रहा है तो इसका क्या क्या हो सकता है. So once you've done that, I can click on this and I can complete it. So now every time this will go above this, it will create an alert and it will create a maintenance activity. Okay, you need to check. You can go to the machine, check these things, and then once it is there, you can take key, is it okay or not. So let's say we can also have QC parameters. Okay, so now you put in QC key, I want to read my current. So I want to read my speed. So now I put these two parameters. So when my PF will go up or I've set this alert, then the activity will be created and your supervisor or your operator or your foreman will be asked to check these things and put in the data before doing checking and after checking. So now let's say he finds that the greasing was not done. So he will put in the before data. What was the current before he did the greasing, and then he will put in the data after he did the greasing. So then you'll know what is the change. That way you can create. Or let's say if you want different parameters, then you can also have different parameters here.
Manish, I think this answers your question. Manish, you're on mute.
Sorry. Yeah, I got it. So means everything is available. Only thing is that we have to create our standard, and based on that standard, the system will give alert, and it will show some remedies also. Right? What checklist that we have submitted, right? Okay, fine. Thank you. Thank you. Thank you.
Thank you. Any other queries? Devarshi, your hand is up from my team. Devarshi, you have any query? I think she lowered the hand. Okay, I think we can wrap up the session. Thank you, Sagar. Thank you for the wonderful presentation and information on this.
So, Himanshu, I think Ankit Bhai had also raised the hand in between. I'm not sure whether he had a question.
Ankit Bhai, you have any query?
Yeah. Can we know the costing for the device which will be attached with the machine? Because there should be something there that is extracting and providing the data to the system live.
Correct. So for costing, we need to speak regarding what kind of machines you have and what are the energy distribution boxes that you have. So how your energy is distributed. Once we see that, once we know it, we can give you a list of devices and along with the pricing for it.
Just an average costing.
Sagar, you can
So,
give a broad idea on type of sensor and the average costing it has.
okay. So average costing, let's say, it can be between 2 lakhs to 5 lakh rupees.
Okay.
But we need to know in details to quote you further.
Mhm. Okay. Thank you.
Any other queries we have? I don't see any hands. Okay. I think we can wrap up this session. So thank you, Sagar, for the wonderful presentation. Those who have not got a chance to attend this, we will be uploading this session at the Knowledge Center. So